P.2quared Journal Entry 11, Helix, Part 2. Date is October 16th, 2021. So today I want to go into further detail about the interactions between a helix constituent and a particle or a cluster of these helix constituents in here. So I'm going to go over the first part of the paper that I am working on, go over the terms, and then go over part 1, like 1 through 3, and talk about what that means in further detail than I did yesterday, and see if we can't get a better explanation than what we had. So the terms that we're going to be using are helix, which in plural is helices, and it's the smallest energy carrying constituent under our consideration for this model. And the second term is particle, which is a cluster of helices. So I may misspeak, I'm going to try not to, but whenever I say particle, what I'm referring to is a subatomic particle under what we would consider a standard model at this point. And when I say helix, I'm talking about that smallest constituent. So, and then before we move on, just one thing that is really important is that as we're going through this discussion, this is not a discussion of what the universe actually is at the smallest points that we can see or that we can observe the effects of. This is a model to help us be able to have more control over the subatomic universe here in the coming years with the development of this hypothesis, if we can transfer it from hypothesis to theory. So let's start going through this first bit of the paper. Part 1.1 says, let us first consider a thought experiment examining the interaction between one helix and one particle. In this experiment, consider the particle to be in an idealized state where none of its helices are in motion relative to any other helix in the particle. Now, let us take one helix, which we will call helix A, the not part of the particle, and send it along its long axis and spinning on its circular face into the particle. We will consider two outcomes from this point in the experiment. So what it's saying is, let us take a particle, so basically where we ended on the last entry, and we're going to consider that this particle has a ton of helices in it that are not moving, right? And these not moving helices are in a state that would never actually happen in a real life particle. There's always energy, there's always motion going through the particle. So for our first experiment, let's just assume that this guy is going to fly into this one helix right here, that he's going to fly into this group of helices. It's going to fly into this particle any which way. So what we're going to discuss is going to apply to the interaction no matter what the orientation of helix A is. So let's go ahead and read the first outcome of our thought experiment. For our first outcome, let us assume that helix A made contact with one of the helices in the particle on the forward moving side of helix A. We'll say that it's this side. So this little piece right here. Since helix A has a certain speed and all helices are to be considered identical, it can be deduced that the interaction between helix A and the particle would have a net effect to send the center mass slightly in the direction that helix A was going. This is because the interaction occurring on the interior of the particle would be that the helices entangled with each other would collide with random angles to each other and helix A due to the orientation of entanglements. After several helical interactions inside the particle, a helix originally a part of the particle would be ejected. Since all particles are to be considered rigid, there would be no residual relative movement in our idealized particle, so it would have returned to its idealized state. This is a negative interaction. So there's a lot there to unpack, but let us look at this sentence. Since helix A has a certain speed, and all helices are to be considered identical, it can be deduced that the interaction between helix A would have the net effect to send the center mass slightly in the direction that helix A was going. What that means is after this helix, so after this charged particle, so after this helix has its interaction, that now it is a part of this particle, and it gets stuck, and it sends its energy that it had through this particle. So let's change colors so that we can ploop. So let's say the energy went here, and then it hit another helix and sent the energy here, and then it hit another helix and sent the energy here, and then hit another helix and sent the energy here, and then hit another helix and sent the energy here, and then hit another helix and sent the energy here, and then hit another helix and sent the energy here, and here, and here. And eventually, on the other side, helix B pops out, right? That's how the energy from helix A would transfer through the particle and end up sending helix out the other side. Now, it doesn't have to be perfectly out the other side. That's super idealized. It could be actually in any direction. It could be here, it could be here, it could be here, depending on the orientation of the particles, or the helixes inside the particle. So the outcome of this interaction would be to have the average density of this particle, to go slightly in this direction because a number of its helices have moved in that direction. So now let's consider the positive interaction. We're going to read 1.3. It says, for our second outcome, let us assume that helix A made contact with one of the helices in the particle along its twisting axis on the opposite side of our particle relative to helix A. With this interaction, we can deduce that the interaction between helix A and the particle would have a net effect to send the center mass slightly in the direction that helix A came from. The same interaction occurs on the interior of the particle as our first outcome in section 1.2, but in the opposite direction. After several helical interactions inside the particle, a helix originally a part of the particle would be ejected in a random direction, returning our particle to its idealized state. This is a positive interaction. So what this is saying is, in this part of our theory, we're not going to allow this thing to spin. We're not going to allow it to do anything crazy. We're just going to send it headlong inside our particle with a collision. So it's twisting like this as it goes. And what's going to happen is, as it comes in contact with a helix inside the particle, instead of, and I'll draw it like this, instead of having an interaction where it bumps on this side, it's going to have an interaction where it bumps on this side. So it's going to act like a corkscrew in a wine bottle, or a screwdriver. It's going to pull this direction even though it is traveling in this direction. So when this particle comes in contact and ends up hitting one of the helices on the inside, what happens is that helix is sent this way, but it's entangled, so it grabs another one and sends it this way. Then it grabs another one and sends it this way. Then it grabs another one and sends it this way. Then it grabs another one and sends it this way. And then it grabs another one and sends it this way. And it doesn't only have to grab in this fashion, it can grab from up here, and then all of a sudden you have one go this way, and then one go this way, and then one go this way. I mean, that's a big jump. I don't think that would actually happen. But then at the end of the day, what you would have is one of these gets in motion and gets detangled and gets shot out, and then becomes a charged particle. that is how a pull interaction would work. And this is the thing that allows us to, let me clean up my screen real quick. And so this is the thing that will allow us to look at the subatomic universe through new eyes, because we have this corkscrew action that these helix particles will be able to affect these large groups of helix constituents with. This alone explains so many things, and we'll go into that in further detail in further entries. But today I really wanted to focus on positive and negative charges, and we'll revisit this because this is very important. I want to make sure that it's explained well. But this little group of helices, that's a particle, and this little helix right here, which I've been referring to as a helix part, or a helix constituent, and a charge particle, it controls the flow of objects through the subatomic universe. So I hope this made sense to anyone who has come across it. In our next entry, we will go over electron orbits and how this affects electron orbits, as well as strong force, weak force, and then we'll also get into radiance, because this also explains why photons are formed out of two electrons colliding together and why gravity exists at all. So stay tuned.